Hey guys, welcome to Simblarosh Builds. Today we're going to build a gimbal for a DSLR camera. Let's get to it. So, most of the gimbals that I've seen online have a long pole with weights on the bottom and the camera is mounted up top. And there's a swindle here where your handle actually connects into, and this is where you hold it, right there. Well, I'm thinking something a little different. They do make gimbals where the DSLR camera sits on bottom, so that's what I'm thinking we're gonna do. So, camera sitting here, we're gonna make a frame that comes around like so, with bearings here and here. And then we will have a 3D printed elbow here with bearings in this direction. And then from here, we will have a final one that's kind of hard to draw here, but this is where your handle is going to go. So we'll have 3 axes, 1, 2, and 3. And hopefully we can guesstimate at the center of gravity on the camera, because if the center of gravity is off by a little bit, this may tend to lean side to side. So from the bottom, I'm thinking that this plate from the bottom, this section here, will cut a slit in it like so, so the camera bolt that actually holds it in is able to slide in both directions. Now that's only going to help us with the forward and backwards, so we'll have to see if I've guesstimated the center of gravity right, left and right. If not, then we'll have to redo this design and possibly modify it. So we'll go to the computer now and we'll try to model this up and see how it looks. So, looks like our print's done. We'll go ahead and pull this guy off of here. I always print with the raft, and I have good luck with it. It makes the prints easier to pull off from the plastic, and also I've had success just pulling the prints off the bid with the raft. Most of the time I don't have to use any kind of, like that, I don't have to use any kind of blade or anything to try to pry it off. It just kind of pops off like that. So we'll take these in the shop and then we'll pull all the support off. All right, guys. So we got the we've got our prints. We're gonna go ahead and pull the support structure off of them. So what I like to do is the ones that don't have support structure, like these small little end caps, they just kind of peel right off the raft. And I print them upside down with the smaller part of the circle up, because the backside generally on the raft doesn't print real great. You can get this better if you play with the first layer settings, but I just, I've been using these same settings for a while and I haven't leveled my bed in like months. So so far it's been holding up pretty well, but see, this area here is actually support. So with the way that I have my supports set up though, I can generally just break them right off of there and it comes off pretty easy. Now granted, this one's not gonna it's not gonna want to cooperate with me, but they normally just kind of crack right off of there. Ah, shit. Okay. So now you can clean this up with a razor blade, which is normally what I do. So what I like to do is get a razor blade, and so I'll get one really quick. Let's see. And then you can kind of take the blade and run it down the edges and trim off any pieces of the plastic that shouldn't be there. And since this piece here is not really a real precise piece. I mean, in the fact that it has to look really good. This is not gonna bother me. This is more of a functional 3D print rather than a cosplay prop that you want to look really nice. So now you can see I have support materials inside the slit here. So this stuff, normally you could pop them out just like that, and it should just slide on out of there. So that's not too bad, and that turned out pretty nice. So and again, this is all how you print. So if you print like I did on its side, then the only support material you're going to away, and everything else is going to be nice and smooth and solid print. So this one's just about done. There's some small holes here that I put for screws. For those guys, sometimes if you can't pop them out with the blade, if you normally cut the ends, they'll pop loose and then you can just push them through. But sometimes they don't, and you may have to get a nail or a small screwdriver and try to break them loose that way. It just depends on how the print is made and the size of the holes. So see this one here, I was able to just pull it right out. See, look, these are just coming right out now. So those are all out of there. So this guy's completely done. So here you've got our handle. Break this guy apart, just kind of pop that off of there. Some more of the joint pieces. So these I don't want to break anything, so I like to pull the support off of the raft first, and then I generally go back and try to clean up the other parts. So let's see, get all this off of here. Come off of there. All right. And some people may, you know, tell me I need to fool with my printer settings, whatever. Yeah, I could probably get it better, but to be honest, this is pretty good. And I haven't touched the printer settings in a long time, and I've been pretty confident in what I have currently, even though sometimes these are a pain to get off and you have to use pliers. So a lot of times I'll use the diagonal pliers that came with the printers, the flush cuts, people call them, these. So a lot of times these will help you to just kind of cut and break apart the supports if they don't want to just pop right off. Normally once you can get them to pop, they just come right out. So this is all trash. Separating the raft. And so for those of you who are maybe new to 3D printing, these types of prints are what's called FDM printers, where you basically have a nozzle that heats the plastic and prints it layer by layer, melted plastic on top of each other. And so FDM printers, while they're cheap and the plastic's fairly cheap too, it doesn't get the level of detail like a resin printer will get, an SLA printer, which I have an SLA printer. It's called an Elgu Mars, and this is off of my Creality CR10 printer, and I'll probably do a review on the two and compare them so that you can see the differences in print and print quality for those of you who don't have a printer and maybe thinking about getting one. I will say this, 3D printing has allowed me to make things that I would have never been able to make before. So it's definitely an awesome tool to have, and it really doesn't matter what kind of work you're interested in. 3D printing has applications, I mean, for almost anything. If you're doing woodworking, you can 3D print tools that you can use to do woodworking. So there's all kinds of applications to use it. And this one is being difficult. So the reason these are so hard is because if you can't see it probably, let's see if I can get a better view for you after I get this out of here. But there's a channel in here that my bearings are meant to ride in, and that channel is making it difficult for the freaking support material to pop out.
So let's see. Now these bearings, I sized these prints with a caliper whenever I was doing the 3D modeling. I used a caliper to measure my bearings, and I did it as precise as I could. So I may end up having an issue where the 3D prints are smaller than what I actually measured because of the way that the printer is calibrated and everything else. It may end up being smaller, and if my holes are smaller, then my bearings are going to have a hard time fitting in them. So we'll have to just wait and see if that's the case. So these are the bearings that I'm going to be using. It's a total of 5 bearings. I'm going to use 2 for one axis, 2 for another axis, and then this will be my swivel bearing. And so there's going to be 5 total. And so just so I can show you you can see the channels. Let me focus the camera. You can see the channels that I've built inside the print that the bearings will ride in. So this is a cap that goes on top of the bearings, but those channels are also built inside of the actual other pieces. So some of these may be a tight fit. So let's just see if this guy fits in here. Wow, that fit a lot better than I thought it was going to fit. That is pretty slick. Okay, same thing with this guy. So the handle should go into one of these bearings. Oh man, this is if that's any indication of how well the others are fitted, then we should be good. Oh man, it's like a freaking glove. Okay, so we'll go ahead, and now that all the support material's off, we'll get ready to assemble it and give it a test. Okay, so first, let's see. The way that I designed this model was the holes are intended for screws. So I could use bolts, but I decided not to, just because screws are more readily available and they're not as hard to find. They're easier to put in, and I just thought it might be easier using screws. So let me grab some screws that we'll use for this guy. And some of them may be longer than others, so I have these, and then I also have some smaller screws. Let's see if I can find some that are decent in length. Maybe some of these here. So we'll see which ones can fit in each application, but these are fairly thick pieces, so I think the bigger screws will probably work. So for this guy, first off, the 2 bearings we're going to use are these types, which these bearings I actually got out of a dirt bike engine, so they're not the standard size. So these should slide into these cutouts that I've put in here, and this is where I'm a little worried that my 3D printing may be too tight, but actually it fit pretty good. So I just pushed them in there and they are in there. So now the cap goes over top. Make sure I got this guy on there right. Okay, like this. Just pushes down on top of that bearing. This seems to look pretty good. So then the caps will go in there, and our screw will go into the next piece. So the next piece will be what will be the next piece? Oh, the large bearing goes in through here. Now that I'm looking at this, I probably should have put the large bearing. I should have started at the handle, so I'm gonna undo this. Keep in mind that all of this was just drawings on a piece of paper. So this is our first prototype, and it may not work out like we planned, and if not, then it's just back to Fusion, and we can tweak the pieces. And I think that I'm I'm using a number 2 Phillips, and this screw is a number 1 because it's not setting down right. So let me see if I have a, and man, I don't have it all the way cinched down. It's very difficult with this piece in the way. So I see that's something that I didn't anticipate. And you know what I could do is put a hole straight through here, large enough for my screwdriver to go through so that I could get to the screw. That's one way to do that. Let's see, for the next piece, I don't think that I'm gonna have any restrictions on accessing it, so I think I can put this back on the main piece here. Again, with the screw, probably could have used a shorter screw, and I may do that just because. And if you guys have any suggestions, please put them in the comments. Again, this is a learning curve for me as well. See, so I can already tell that it's off canter, but that's with no weight on it. So once the camera's on it, it will hopefully kind of flatten it out. At least that's what I'm hoping. So the last piece is the 2 bearings inside of this sleeve. So these guys will just kind of have to pop in. And I think that I made one of these lips smaller than the other. Yeah. Actually, I made them both small, but. Okay. All right, they fell into place. So I don't know if you're able to see it, but 2 bearings are in place. Handle goes through here like so, and then the last cap, the last cap goes there. So I only have one DSLR camera, so when we actually go to mount it, I'm gonna have to use some other camera to record the footage. I guess I'll just use my cell phone. It's probably the next best camera that I have, and we'll see how it acts with the camera weight on it, if it actually holds it steady. Okay guys, so I got the camera mounted, and I know we're on my cell phone now, so the quality is probably not as good, but I was able to find a screw. Couldn't find one the right length, so I had to use a nut to actually act as kind of like a stopper. But I did get the camera mounted on it, and I'm actually pretty surprised at how well the center of gravity turned out on this guy. I feel like it's pretty much level. Like maybe the camera could slide slightly to the right, but it's not even really that noticeable. So what I'm gonna do is I'm gonna turn the camera on now, and I will start some footage from the camera so we can run that through and see how that looks. Let me just tighten this little bolt up on the bottom. And so my camera, this lens doesn't autofocus, so I kind of have to manually focus where I'm gonna go. But let's try to do a recording here and see. So one thing I do notice is that the handle is not the best design. So I need to work on that. But I'll let you guys know. So, but as far as being a smooth gliding motion, you can actually kind of control the way that the camera turns by twisting the handle. I think it's pretty decent. You can actually I'm actually twisting the handle and it's making it turn, but if you get practice with it enough, I think you could get it to where you can get some cool stuff out of it. And then you can turn it, so if I want to hold, I can kind of hold my thumb against this piece here to do the turning. And so what I kind of noticed is I can control the turn with that hand as well. And again, this takes practice, I guess, because I'm not the best person to be doing this. I've not really played with gimbals much ever, so let's see if we can get it to focus up close. Let's see, that's about the sweet spot there. So I mean, it's not bad. It's not bad. So, all right, guys. Well, that's it for today. Let me know what you think. Comment, like, share, subscribe. Anything you guys want to see, let me know. I think my next video is going to be more on the 3D printers themselves, maybe some reviews and looks at how mine are set up. Thanks for watching. See you later.